welcome back to another video of CHE 101. I am Angela Kuwili, and for today's topic, we will be dealing with the perpetual motion machines under Chemical Engineering Thermodynamics. So for the outline of today's discussion, we will first have a brief review of the laws of thermodynamics, which mainly are the first law and the second law. Then we will deal with the violations to the laws of thermodynamics of the perpetual machines. Then we will have a sample problem dealing with the maximum work and identifying the violations to the laws of thermodynamics. And finally, we will be summarizing today's discussion. So for the laws of thermodynamics, we have the first law, which states that energy can be converted from one form to another with the interaction of heat, work, and internal energy, but it cannot be created nor destroyed under any circumstances. So the emphasis here is that the first law of thermodynamics and that the energy cannot be created nor destroyed. So the energy, regardless of the form, should be balanced. And for the second law of thermodynamics, it deals with the entropy of the system, which says that the state of entropy of the entire universe as an isolated system will always increase over time. So entropy of the entire universe should always be positive. And now, dealing with the perpetual motion machines, we have the first kind, or the PMM1, which violates the first law of thermodynamics, since it produces useful energy work without energy source, or produces more energy than consumed. This violates the first law, since energy cannot be created, and in this type of machine, work is created without any type of energy source. And for the second kind of perpetual motion machine, or PMM2, this violates the second law of thermodynamics, as it produces useful energy work from a single reservoir in equilibrium only, or produces more work than energy consumed, which indicates that it has a higher efficiency than the ideal Carnot cycle, which is not possible since entropy of the entire universe should always be increasing and that the efficiency should be lower, and meaning that the work should be less than the heat source. Now, we can now solve for a problem, and the problem statement is the hot and cold reservoirs of an engine are at temperatures of 1000 Kelvin and 350 Kelvin respectively. What is the maximum work produced by an engine operating in the given temperature range if 4000 kilojoules is transferred from the hot reservoir? And second, determine which of the heat engines shown in the table operating in the same temperature range obeys the first and second laws of thermodynamics. So we have 5 engines here, and the heat from the hot reservoir and heat to the cold reservoir and the work produced are stated. So first, we will solve the maximum work allowed here. And for the given diagram, we have temperature of the hot reservoir to be equal to 1000 Kelvin with a heat transfer of 4000 kilojoules. Then the heat engine produces maximum work and a heat that is transferred to the cold reservoir that is at temperature 350 Kelvin. So we also have the table here for the 5 engines, and the required are the maximum work and engines that are neither PMM1 nor PMM2, so that they are possible in real life situations. And for the solution, we have the equation for the efficiency of the Carnot cycle, which is equal to 1 minus the temperature of the cold reservoir over the temperature of the hot reservoir. So we get this because the second law states that the efficiency of the Carnot cycle should always is the maximum possible allowable work. And substituting the values, we get that 1 minus 350 over 1000, which is equal to 0.65, or the efficiency of the Carnot cycle is 65%. So for the maximum possible work, we have the efficiency multiplied by the heat from the hot reservoir, which is equal to 65% multiplied by 4000 kilojoules, which is equal to 2600 kilojoules. Now we will solve if each of the engine violates the first or the second law. And for the first law, the energy should be balanced, and for the second law, the efficiency of the engine should be less than the efficiency of the Carnot cycle. So for the first, we have 4000 equals 800 plus 3200, which is equal. So this does not violate the first law. And for the efficiency, since the work is 3200 all over the heat, which is 4000, it is 0.8, which is higher than 0.65. So this violates the second law. For the second engine, the energy balance is equal, so it does not violate the first law. And for the efficiency, it is less than 65.65, so it does not violate the second law, so it is possible. Then for the third, the energy is not balanced since more is produced than the absorbed. And for the efficiency, it is less than, so it does not violate the second law. And for the fourth, it is also not balanced. And for the efficiency, it is lower than the 65%, so it does not violate the second law. And for the last, the fifth, the energy is balanced and the entropy and the efficiency is less than 65%. So only the second and the fifth engines obey the first and second laws of thermodynamics, so they are possible in real life. And for the complete solution, you can pause here to take a screenshot. And to summarize our discussion, we have first, PMM1 violates the first law of thermodynamics, so there is no energy balance, or the energy is not balanced. And for the second, PMM2 violates the second law of thermodynamics, which means that work produced exceeds maximum work possible. So that is all for today's discussion. If you have any questions, you can send them through our Gmail, chen.acads@gmail.com, or through our Facebook page, which is Chen Acads Hub. So thank you and have a blessed day.